Hi everyone, welcome back to Tech Explained Simply. In our first video, we saw how Spotify predicts your favorite song using collaborative filtering and natural language processing. Today, we are going deeper into how recommender systems, the engines behind those suggestions, really work. In the next few minutes, I'll take you through two key approaches: collaborative filtering and content-based filtering, and show how they power the apps and sites you use every day. Let's think about this. You open a streaming service, an online store, or a news app, and you see a list of items recommended for you. As we stated before, this is not magic. It's machine learning. Recommender systems help users find what they are likely to like and help platforms engage, retain, and upsell. According to standard definitions, a recommender system is a subtype of information filtering that predicts a user's preferences based on past behavior or item characteristics. So as we mentioned, there are two approaches. First one is collaborative filtering. And the idea of collaborative filtering is if two users behaved similarly in the past, then their future preferences might also align. For example, if Anna and Bob both like songs Shape of You and Abracadabra, and user Anna also liked song Flowers, then we may recommend Flowers to Bob. This is users like you also liked. It uses user-item interaction history rather than understanding item content. There are memory-based methods and model-based methods. For example, matrix factorization decomposes the user-item interaction matrix into latent user factors and latent item factors. There are, of course, pros and cons of this approach. So pros will be that it can capture complex taste patterns, and it doesn't need item content metadata, while cons or challenges would be a cold start. So we don't have any data for new users or items. And sparsity, which is a lot of users and a lot of items, but few interactions. On the other side, we have content-based filtering. This is the second approach. This one looks at the items and the user's profile of what features they like. For example, if you liked songs with genre jazz and mood relaxed, we'll recommend other songs labeled jazz and relaxed. It creates a user profile and compares to the item's features. Pros of this method will be that it works when you have good item metadata and it can recommend new items, so no user history is needed in this case. And the cons would be that it is limited by what you know about the item content. For example, it tends to recommend stuff also very similar to what you already liked, so there is less novelty. Maybe I will like something more than that, but I wasn't recommended. This looks like this in a book. Why? So in the real-world systems, they often combine both. And we call this a hybrid recommender. It uses content features plus collaborative signals. This helps alleviate limitations of each single method, like cold start, over-specialization, and sparsity. So you've seen recommender systems everywhere. Spotify uses it to suggest your next favorite track, as we mentioned in the first video. Netflix recommends what to binge next, and Amazon shows products you are most likely to buy. But behind the scenes, building these systems isn't easy. They have to deal with scalability, which is millions of users and items being processed in real time. They have to deal with freshness, meaning keeping recommendations up to date as user tastes change daily, and the diversity versus relevance trade-off. So finding a balance between giving you what you'll probably like and still surprising you with something new. That's the magic formula that keeps you scrolling, listening, and buying, all powered by data and machine learning. To summarize, recommender systems are one of the most powerful ML applications you interact with every day. Collaborative filtering uses user behavior patterns, Content-based uses item attributes. A well-designed system blends both. Next time you see a because you watched or recommended for you, you'll know there is a whole engine behind it. And if you like this video, be sure to hit subscribe. And in the next one, we'll dive into how NLP and embeddings power recommendations behind the scene. Yes, back to the tech you loved in our first video. Thanks for watching, and see you next time.